All right, now we want to talk about vectors in coordinate systems. Okay, so if we're looking at vectors in the coordinate plane, so I'm going to go ahead and draw just regular Cartesian coordinates here. Okay, X and your Y value. We're looking at vectors in the coordinate plane. Once again, we said it's standard position if you start at the origin. Okay, and let's say I've got this vector that ends at the point 3, 1, 2, 3. Ooh. The point 3, 4. All right, I've got a vector that starts at the origin and ends at 3, 4. Okay. Started at the origin and I end at 3, 4. Okay, that's my vector A. To denote this vector, we use what we call component form of this vector. In other words, my X component of this vector is 3. My Y component of this vector is 4. Okay, this would be vector 3, 4. Notice, it is not 0.34, and what we use is these angle brackets. Okay, we use these angle brackets to denote the vector 3, 4. The 0.34 we use parentheses, right? But the angle brackets are used to denote the vector 3, 4. Notice the difference. There is definitely a difference. But you can see that 3, 4 is just representative of this vector. Now, here's the beautiful thing about vectors. I can move them around. And what do I mean by the fact that I can move them around? It means that it doesn't matter really where the initial point is as long as I finish this way. And I'll explain what I mean. So for example, let's say instead I wanted the vector, let's see. Let's say we go, let's see, 1, 2, -3, let's see, this is -2. So we're at the point -3, -2. Let's say my initial point is -3, -2. And let's say my terminal point is 0, 2. My initial point is -3, -2. And my terminal point is 0, 2. Well, let's count. What's the X component? What's the X component here? Well, let's think about it. I'm going up 1, 2, 3. I'm going 3 in a positive way. I'm going up 3. So, okay. And this is the vector, by the way. And let's see. How much, I'm going 3 in the X direction, in the positive X direction. And I'm going 3 up in the Y direction. Or actually 4, my bad. We're going 1, 2, 3, 4 in the Y direction. Wait a minute. This is just my vector A. Notice it actually does not matter where your terminal and initial points are. This vector 3, 4 just denotes how I get from this point right here to somewhere else in space that was 3 over and 4 up. Okay? Notice these two vectors, of course, are the exact same. These are what we call equivalent vectors. All right, now that we've talked about that, let's talk about the magnitude of vectors. The magnitude of some vectors. Same vector. I just wanted some space real quick. But let's look at the same vector 3, 4. Okay, let's just look at it for a second. And this is my vector right here. What's the magnitude? Before I solve it, I'm going to give you about 5 seconds to figure it out. All right, did you get it? I hope you paused the video. Here's what we're going to do to figure out the magnitude. Well, once again, let's just remember our point was 3, 4. Our vector, of course, in component form is 3, 4. Let's think about it. We went 3, let me get a different color here. We went 3 in this direction, and we went, it should be up here a little bit. Let me fix that real quick. Okay. All right, and we went 4 up. What could we use to figure this thing out? If you said Pythagorean theorem, you're absolutely right. Let's think about it. This is going to be 3 squared plus 4 squared equals x squared. This is a Pythagorean triple, yes, but let's just go through it. That's 9 plus 16 equals x squared. So x squared equals 25. X equals 5. It's pretty easy to tell this now. The magnitude of this vector is 5. Now, what is the technical term of this? Well, let's think about it. If I have vector in component form, 3, 4, another way we can write that is vector I, J. Once again, I is just telling me the x value of my vector. J is telling me the y value of my vector. And so to figure out the magnitude, which by the way is denoted as the magnitude like this, it's just going to be the square root I squared plus j squared. That's it. Why? Because it's just the Pythagorean theorem, just like we showed before. Basically, once again, just looking at it, it's my x component and my y component, right? It's my x component squared plus my y component squared, and we're taking the square root of that. It's really that simple. So magnitude, just remember, basically, you're just trying to figure out distance, and it's very similar to the distance formula, only in this case, you're already given the components that you need. All right, last but not least, well, actually, before I move on, let's do one more problem. Let's say that you're given, I don't know, 2, 6 is the vector. What's the magnitude? It's going to be square root of 2 squared plus 6 squared. Square root of 4 plus 36. Square root of 40. Which ends up being 2 root 10. That's your answer. Y'all see how quick that is? If you know what you're talking about, it's real easy to figure out what is going on. All right, so let's determine some components given some points, okay? So let's say that I've got an initial point 4, 0, and I have a terminal point. Actually, let's make it out here. 1, 1, or negative 1, 1 rather. And I want to figure out what is the component form of this vector. I'm going to call it B. We've been using A a lot. I want to figure out the component form for vector B. Okay? How do I do that? Well, it's real simple. Think about it. I'm starting at 4, ending at negative 1. Am I going forward or am I going backward? I'm going backwards. I'm going backwards by how many units? 5. All right. Am I going up or am I going down? Well, I'm going up. I went back 5 units, negative 5, right? 1, 2, 3, 4, or 1, 2, 3, oops. This is why you should do this first, but 1, 2, 3, 4, 5. I went back 5 units and I went up 1 unit. So -5, 1, that is the component form of my vector. Really that simple. Is there a formula? Yes. I'm not going to cover it here because it's really that simple. So if I give you, I say, hey, find the vector between the points -8, -8, and 2, 10. Okay, if this is the initial point and this is the terminal point, let's think about it. From -8 to 2, how far am I going up? Am I going down? Well, I'm becoming more positive, right? By how much? 10. -8 to 10, am I going up? I'm going down. Up. By how much? 18. So that's my vector. It's really not hard to find vectors between 2 points. All you got to do is think about what in the world does it mean. Now, we can also add vectors to each other. Same scenario. Same scenario. Only I'm actually going to use, let me see here. Let me give myself a little bit more space here. All right. So let's say we have the vector 2, 3, 4. We got 1, 2. The vector 3, 4. It's our vector A. And let's say our vector B, okay, is the vector 0, 2. Now, what does 0, 2 mean in terms of a vector? Well, think about it. It means we're not going anywhere in the x direction, but we're going to go up 2. So, obviously, it terminates at 0 at 4, 5 if we're adding these two together. We're going to add these two together. And we want to figure out what the vector is when we add them together. In other words, we want to find this green that starts here and ends here. Well, let's think about it. What does that mean? Well, obviously this point, just so that we know, you could tell me is 4, 5, right? That's the point. If that point is 4, 5, oh, by the way, this point is 4, 3. That point is 4, 5. We know that the resultant vector, since it's in standard position, is 4, 5. But let's look deeper into it because we want to figure out how do we figure that out. Well, think about it. Our vector A was 4, 3. Our vector B was 0, 2. So if I add 4, 3 plus 0, 2, I get, well, 4 plus 0 is 4. 3 plus 2 is 5. So my A plus B vector has to be 4, 5. All you do is add the components. Literally that simple. Subtraction, the exact same way. Remember, whenever we subtract, we're just multiplying by the scalar -1. That's it. That's all you do. It's really not hard at all. All right, so let's do a couple of problems real quick. All right, so let's say that you got the vector 3, 4 and -2, 6. Yeah, the vectors 3, 4 and -2, 6. And I ask you, and let's call this as, let's say this is vector V, and let's say this is vector W. And I ask you, what is 2V minus 3W? It's real simple. all you do, first of all, 2v has to be 6, 8. In other words, I've just multiplied by a scalar. I have scaled it. I've made it bigger by a factor of 2. So you just multiply each of these components by your scalar, which is 2 in this case. So 2 times 3 is 6. 2 times 4 is 8. Negative 3w. Well, negative 3 times negative 2 is 6. Negative 3 times 6 is negative 18. So those are my two component vectors. Now, all I got to do is add them together. I went ahead and multiplied by negative 3, so it's not really subtraction. So I just got to add these two together. And my resultant vector becomes 12, 10. Y'all see how easy this is? It's really not that bad. So, as always, don't forget to like, subscribe, hit the notification bell, check out my website, do all of the things so we can grow this channel. Until next time, love you guys. Take care.